Could you please take your seats? We would like to continue with the next panel. And I hand over to Jim, whom we are happy to have as moderator of the business models and interoperability session.
Thanks very much for that, Carla. So I'm going to try and keep this this session crisp and according to time, and leave lots of time for questions at the end of it. My contribution to that will be a very quick introduction and no more. So about me, I'm founder and chief research officer of a company called Makina Research, which was subsumed into Gartner at the end of last year. So I guess that makes me a Gartner person for now. I'm also chair of business strategy for the Industrial Internet Consortium, which is the #1 IoT consortium out there. So I have a bit of a perspective on business models, but this panel's about these guys and about standardization and interoperability, specifically the diversity of business models and interoperability. So IoT is extremely diverse. We're talking here about a connected world. So you look outside, there's a whole world out there, and if we're going to connect all of it, IoT is as diverse and as fragmented as everything you would encounter outside of this room. It's incredibly fragmented. I mean, fragmented doesn't come close to describing how complex and diverse this space really is. In this session, we're going to explore the work of organizations involved in standardization and interoperability, possible benefits of proprietary standards for various use cases, whether the IoT sector is yet mature enough for any form of standardization, the state of the art in standardization, and you know, specifically with reference to some mobile concepts, particularly over-the-air provisioning, OTA provisioning, and also the role of operating systems and platforms in this space. The speaking order is going to vary slightly from, or completely in fact, from that listed in the program, just to put a logical sequence, I think, behind these, what these guys are going to say. So we're going to start off with Vodafone. Robert McDougall is going to give us a telco's perspective on IoT and what those guys are doing and how they engage in the market. Then we're going to move to 1M2M, represented by Omar Elumi, who's going to look at issues around changing device connectivity and what 1M2M can contribute. Sigfox is going to give the perspective from a non-3GPP operator and player in this space. We've got a substitute there. So welcome and thanks for stepping in, Rahul Mayat, who's VP in charge of innovation and R&D. And then we're going to finish up with IoT WG3. That's the European Alliance of IoT Innovation, IoT Standardization. That's Patrick Guillemin, who's going to contribute. Guillemin. I'm sure he can pronounce his name better than I can. And then we're going to follow by a panel discussion. And we're going to aim for 10 minutes per presentation, and after 12 minutes, you'll notice me pulling these guys off so that we can have a lot of time for questions. That's it. So, Robert, please.
Thank you, Jim, and good morning, everyone. And so my name is Robert McDougall, and I lead on IoT within the Vodafone Group Public Policy team. Really, my brief introductory remarks this morning. First of all, I want to set out a little bit of regulatory and policy context, obviously further to Francesco and Cara's overview of the BEREC report. I then want to give a little bit of an insight into Vodafone's approach to IoT. Then I want to give an update on over-the-air provisioning, which is something I've specifically been asked to do. Then I want to conclude just with some key policy recommendations from Vodafone's point of view. And if we could move to the next slide, please. Yeah. There we are. Thank you. So a little bit of regulatory and policy context. I've identified 4 different initiatives here, given the stated objectives of the panel. The first is the Commission's recent communication on platforms. Given we've been asked to consider the role of platforms, and the Commission obviously looked at platforms, the benefits of open platforms, the benefits of closed platforms. So I think that's relevant context. Then next, it's already been mentioned this morning, the new proposed Electronic Communications Code, Article 87, specifically highlights the role of member states to promote, where technically feasible, over-the-air provisioning for essentially machine-to-machine services. Interesting point about this is that it's by end users other than consumers. So, the assumption here is these are measures would be targeted business customers. A customer base not typically associated with the existing Universal Service Directive, for example. Next, we have intelligent transportation systems. Now, this is a very specific point in relation to the interoperability of connected car applications, which is something we've been thinking a lot about recently. We have the Commission's recent master plan in this area, also a recent RSPG draft opinion on ITS. So this is around the different types of connected car applications, and I'll briefly give a case study on that, just to highlight why I think that's relevant. And then finally, I think a panelist in the last panel mentioned it, the recent Commission consultation on building the European data economy. And paraphrasing wildly, I would say the suggestion there is perhaps there could be a regulatory regime around access to machine data. So I think that's a relevant context for this panel as well. In terms of Vodafone's objective, how Vodafone approaches this, our vision is to connect every machine to transform lives and business. We do that through our IoT platform. We have approximately 45 million SIMs connected to that platform. I think it was Peter earlier today that suggested it would be really good to have case studies just to highlight what IoT means in practice. Well, on our website, we have a lot of them. I mean, this is a very real part of our business. It's fast growing, and just to put that number in terms of the number of SIMs in the context a little bit, it's over twice as many mobile phone subscribers as we have in the UK. So it's a very important part of our business. We're connecting a wide variety of businesses to that platform, enabling them to connect their previously undigitized assets, and we do that through a range of market sectors, whether it's automotive, utilities, wearables. Important point to mention here as well is this is not a closed platform. We have resellers on this platform. And we do that because the IoT market is quite so fragmented. We have those arrangements in place because it's necessary and it's economically sensible to do that. So that's the way that market is functioning at the moment from our point of view. It's not just mobile, I think is the point of this slide. Mobile is clearly important. It's a technology that's continued to evolve. At the bottom there you have our NB-IoT capability. That's a standard that's recently been standardized by 3GPP pretty rapidly, as I understand it. I think it was 8 or 9 months that it was standardized. We just launched that as a commercial network in Spain. So we think that's really important for the next wave of IoT devices, smart meters that require sort of higher battery and stronger signal, for example. So that's a very important section for us. But we also have fixed capability, the likes of National Grid in the UK connected using fixed IoT capability. Satellite, you might not usually associate that with Vodafone. We have recently concluded a roaming agreement with Inmarsat to connect customers in more geographically diverse locations. Also then the installed base of 2G, 3G, and also 4G mobile IoT connections. And transitioning to 4G plus, as we move towards 5G, and we see 4G plus is really a gateway service to 5G. An example here is Cellular V2X, which again is another specification which 3GPP has been working on. We think this is really important for driving the next wave of connected car applications. Vehicle-to-vehicle services, so cars are communicating with each other. Vehicle-to-infrastructure services, cars communicating with roadside infrastructure like traffic lights. And the point here is that the Commission has harmonized the 5.9 gigahertz band across the EU for safety-related ITS services. And we think it's important that these services are deployed using both Cellular V2X and the existing Wi-Fi capability in this area, which is 802.11p, it's IEEE 802.11p. So there's two different types of technologies there, and the RSPG draft opinion in this area has highlighted the technologically neutral approach of regulators, but we think that there's further work that needs to be done in order to implement that approach in practice. That could involve partitioning of that band, or perhaps novel ways of authorization of vehicle-to-vehicle, vehicle-to-infrastructure services. So I highlight that because I think that can be considered as a type of interoperability challenge that we currently face in the IoT environment. Now I move on to over-the-air, and as I mentioned, I've been specifically asked to give an update on that. The policy context, again, just to recap, is the new Electronic Communications Code, the proposed code, which highlights the member states, are encouraged to promote these measures wherever technically feasible. So as Vodafone, we're very supportive of over-the-air capability, and we want our customers to have the choice as to whether they want, a SIM that might not have over-the-air capability, or that they want over-the-air capable SIM. By over-the-air, just for those maybe just that aren't following this as closely as others, that's a SIM that can basically be transferred from one operator to another without physically swapping out the SIM. So it has the functionality that SIM profile can be swapped from one operator to another over the air. And this is seen to be an important functionality in the IoT market, because a lot of M2M and IoT SIMs might be in hard to reach locations where it's not practical to go and swap out the SIM physically. What I would say is that the market hasn't taken off as quickly as we would like, and we see there's two real reasons for that. One is the cost of the over-the-air functionality, or the EU ICC functionality. Anecdotally, I'm told that it can be up to 5 times as much as a typical IoT SIM. And the other is a historic lack of SIM vendor interoperability. Maybe if I just give an example to highlight what I mean by that. So this type of switch, we can think of a business customer that might be connected to an IoT platform. Say they have 50,000 SIMs connected in their installed base of vending machines. And they want to swap those SIMs from operator A to operator B. And historically, they could only do that using the existing specification if both operator A and operator B had the same SIM vendor, which wasn't always the case. But the good news is that these issues are being addressed. And I would highlight the work of the GSMA in this area. Their most recent remote SIM specification 3.1 from May 2016, that's SIM vendor interoperable. So that gets across that problem of both operator A and operator B needing to be using the SIM vendor. So we think that will help spur adoption. And there's also 3 specific initiatives that we think need to be worked on to really help grow the market and to facilitate OTA really picking up. The first is around the GSMA EU ICC proof of concept on the business process templates. So this is something Vodafone's a lead operator in this work, and that's the processes which will be triggered when a customer wants to move from one mobile operator to another for its installed base of M2M or IoT connections. The second is then developing sort of the technical messaging system that will also underpin that transfer. And there's work currently underway within essentially the wholesale working group of the GSMA. So the bit of the GSMA that's historically been responsible for roaming and roaming agreements between operators, this is a topic that's been discussed in that context. And the third, and we think very important piece of the puzzle to really spur OTA adoption, is the creation of an independent entity that will oversee the switching process. And my penultimate slide, I'll just give you a bit of an elaboration on what that means in practice. So, you can see in the slide in front of you there, we describe this as a clearinghouse. And perhaps that is one way of looking at it, in the way that we have a clearinghouse for checks in the financial services industry. We can have an independent third party that will be responsible for migrating the switching process of 50,000 SIMs from operator A to operator B. And that independent entity will have important responsibilities, such as managing the registration database, keeping a record of what transactions have happened, ensuring that the SLAs are clear in terms of the processes which will be associated with that switch, and then enforcing those SLAs in practice. And there is a comparison, there's a parallel with existing processes and systems in respect of number portability. So my concluding slide, Vodafone's policy recommendations. The first is we think that supportive regulatory policy in this area to facilitate the creation of an independent entity will be welcome. And I use the word facilitate because I think that was a word that was mentioned by Francesco and Cara earlier. So I think this is a good example of berec facilitating the growth of the IoT market in the way that I've described. Important point here is that customers should have the choice which type of SIM they want, whether it is an over-the-air capable SIM or whether it is a traditional physical SIM, because there's no one-size-fits-all approach. And as an operator, we have to be able to meet the needs of the customer, or to be frank, somebody else will. The second point, just going back to my Spectrum example, the interoperability challenges associated with connected car applications in the 5.9 gigahertz band. We envisage here potentially the need for a European Commission delegated act, which will set out the basis in which Cellular V2X and IEEE 802.11p will coexist in the 5.9 gigahertz band. That could include partitioning or a new form of authorization. And finally, from me, which I haven't really developed during my introductory remarks, but it's the idea of regulated access to platforms or regulated access to data. I mean, our view is that that sort of regime would be a disincentive to innovation in this area, and that those investing in IoT technology, they need to have the right incentives to do that, and that the regulatory focus should be on access to public sector machine data. As we've already seen, for example, such as multimodal transport data, we think there's lots more, room to develop policy in that area, and there are already ongoing initiatives. The GSMA has an ongoing big data activity, which is looking to develop common APIs for sharing of data in an IoT environment, as well as the work of AIoTI and ETSI, which are very relevant here. So I will leave it there and hand over to the next panelist. Thank you.
Thank you for this introduction. My name is Omar Lumia. I work for Nokia. That's the company that pays my salary. But I'm the technical plenary chair of 1M2M, and I will say a few words about 1M2M. And I will also stick to the 10 minutes so that we can allow some time for discussion. I like your slide about this centralized model with subscription manager and the peer-to-peer model, because we have been discussing this yesterday over dinner. And I think that's perfectly aligned with that discussion. Now, in 1M2M, we are comfortable with the notion of changing the network subscription, because we make a split between the service subscription and the network subscription, and we manage to maintain during the life cycle of the device this association between the service subscription and the network subscription. That's one concept which I think it's important for this community. We are equally comfortable with the different access technology. I think there is no way we can skip this competition. Of course, as in any market, there is time for competition, and there will be some consolidation at some point in time, but we build the platform in a way that's access agnostic. We are comfortable for a device which has multiple network interfaces as well. One is available at a certain point in time, but not all the time. So let me say a few words about 1M2M. So we are a partnership project. We are very, very similar to 3GPP that probably a lot of people will know here. And we combine the strengths. So we decided to stop working in HC, in Artis, in TIA, in different regions of the world, and join forces in order to try to develop a single standard for IoT service layer. So we develop technical specifications and technical reports which are applicable to what we call the M2M common service layer. So what's the common service layer? So it's a software framework. It's located between the M2M applications and the communication hardware and software, be it in the cloud, in the gateway, or in the device. It provides functions that M2M applications, regardless of the different vertical sectors, will need. So we expose them to application developers by means of APIs. It's like an Android. It's like an operating system for the Internet of Things. But this time around, it's something based on open specifications. So nobody owns the system by himself. So I can have a Vodafone talking to an Orange platform, for instance. The work we do is based on, we want this platform to be multi-service. So we develop use cases from the different vertical segments, we derive requirements, and we write the technical specification and technical reports. We don't have provisions in 1M2M for open source, but there are multiple open source implementations that exist out there, and we see them as extremely important to develop the market and expedite deployment and off-the-shelf devices and interoperability. So we want to move from the left-hand side of the figure to the right-hand side of the figure, where you have thinner applications because the application focus on the business logic. We have the devices which run application. They could access multiple networks. And IoT is about digital representation of the physical resources to a digital infrastructure. So we represent any resources. Could be thermostats, in the digital world. It means we represent them as a means of resources. Let me, and in the interest of time, let me jump to the kernel of the problem. And here I give you one M2M perspective on identification. So let's start with a device. A device may have multiple network interfaces. This is fully recognized in our specifications. For instance, 3GPP, Wi-Fi, Sigfox, LoRa, and each interface should have its own network identifier. In the cellular world, I think you are familiar with E164, MSI SDN, and in the future, it's going to be external identifiers, which are in the form of FQDNs maybe. Those should not be confused with network addresses. And I see all the debate about using IPv6 address as identifier, and I think that's not necessarily going in the right direction, but we could extend on that afterwards. So we acknowledge in our requirements that the network identifier may change over the life cycle of the device. If you consider IoT, then some of the devices out there are going to be deployed for 20, 30 years. This is the case for smart meters, for example. And it's very, very important that you give the freedom for the users to switch the connectivity provider, for instance. And in our work, this is perfectly feasible. And now the devices are going to run multiple applications. You don't expect the device to be a single applications, and those will have also their identities. The devices will expose resources, which are the documents, or let's say a piece of document that you can that they have their own identifiers and that you can go and read, provided you have access rights for them. So what we see is we have service identifiers. That's the one that you see on the top. I don't know if I can put the red light. So service identifiers, which is the device service aspect. And we say that a service identifier could use multiple network identifiers. And it means that I can change the network identifier if I change the network subscription during the life cycle of the device without impacting the IoT service. And equally, I can have multiple network subscription at a certain point in time. But still, I will be able to collect the data or exchange the data with the device. It could be based on policies. I could have policies based on the time of the days or any rating provided by a network communications provider. And of course, the network ID will correspond to a network address, which the device can update in a dynamic manner to our service layer. Of course, it's not about the service, it's about the applications on the device which will need to exchange data. So we have application instances that are reachable about those service identifiers. And this picture is a simplification because there are a need for much more identifiers in terms of resources that will represent these physical entities. So from our perspective, and regardless of the framework, I think we think that those are very important guiding principles if you want to build an IoT system that's sustainable over time, which are, we should dissociate this notion of network subscription from the service and IoT subscription. Very important one. And we should be able to switch and change the network subscriptions during the life cycle of the service subscription. And we do this by means of dissociations. I don't use E164 number to identify a service subscription. It's very important. Now, number portability. We came across the conclusion that number portability is not as a strong requirement as for the case of personal communication. I don't know if you have the same conclusions or not in your work, because for personal communications, you need to stick to a number. And for IoT, I can reprogram the number. Now, network identifiers are not visible in our work to the applications. They could change. There could be multiple network identifiers at a certain point in time because the device is connected multiple times through multiple networks. And we make an abstraction layer in order to allow this to happen. The selection of the network identifier to be used depends on availability, any policies. And in 5G, this is also an important concept because it's a world where we will have ubiquitous connectivity and applications need to rely on IDs depending on the actual used network. So I finished my presentation.
Thank you.
And
Sigfox, next up, row, please.
Okay, good morning, everyone. So I'm pleased to be with you. So I am replacing my colleague Guillaume Binoche, who was supposed to come here. He has a flu, so I just came to replace him. I'm going to show the what we are trying to do in Sigfox. So basically, what I want to talk today is about massive IoT and what are the challenges that we faced when we are dealing with massive IoT. But first of all, we need to define what is a massive IoT. So what we believe is in massive IoT is that is the ability of connecting a huge number of devices, meaning that we want to be able to connect almost any device in the that are around us. And so this is the challenge we are faced and what we want to achieve. So there are four main challenges that need to be addressed here. The first one is about the cost of the complete system and of the devices. So if you want to be able to connect everything, you need to be low cost. You need to be global as well because the devices are all over the place and the devices can move across countries. So you need to be able to address globally the devices. You need to be able to run on a low power because all these devices which will be all over the place are not always connected to a power supply, and so they will need to run on batteries or even to do some energy harvesting to be autonomous. So these are key elements that we need to address, but at the end, in order to deploy the market, to deploy all of this, it has to be easy to use, easy to deploy, so that we can go fast. And so this with these principles, and when we are able to create this massive IoT, we believe that we can produce more. If you are going to industry or to do efficiency in the business, you could be able to produce more with less, and you can also create new services, create new value and jobs for Europe if we are talking about Europe. So these are the goals that we are looking for. So the way we address it in Sigfox is we have I show here the way we approach the paradigm we use for that, and I show from left to right the chain from the device to the application and where we are located. So Sigfox is not doing the devices themselves. We are providing and letting companies or users or customers develop and deploy their own devices. What these devices require an ecosystem of electronics, and what we have chosen for Sigfox is to use existing semiconductor that can be used with Sigfox just by a software update. So all the implementation of software of Sigfox relies on software on top of existing semiconductor, and therefore we provide this as a royalty-free software so that we can open an ecosystem and go towards a low cost. The devices, once they are deployed, they can send data when they need to send data. They're not controlled by the network. And the network is there just to collect the data that the devices send. So this data, which is collected by the network of antennas of access points, is sent to a cloud. So I have a centralized cloud, which is an approach which is similar to some principles that are considered for the 5G approach. So it's a completely flat network where all the core network is on internet. And once you have this core network, which is completely flat, so the access points directly connected to the internet, some processing on the cloud, I can deliver the data which was collected by the antennas to my customers through internet APIs, which is giving an interoperability layer so that it's quite easy to connect an application to the Sigfox network. And then the customers, which are typically businesses for Sigfox, will use this data to have insights on the business and take decisions and improve their processes or do whatever they need to do. So what we see in this approach is that we have a strong interoperability layer at the data level, and we have a very open ecosystem at the device level, and in the middle we provide the service. So from the business point of view, it's an operator business model. So we sell subscriptions to this service. So all this is applicable to many industries. So I have some examples here from agriculture to automotive and fleet management. I have public sector, smart cities, for example, utilities, retail, many sectors, and you can think it's very easy to find new applications for this the IoT when you start to think about it, and when you know that deploying the service is very low cost, you can believe that you can imagine that you can deploy many devices to solve many use cases. So many industries are applicable. What I said at the beginning is that one of the challenges is to be global. So as Sigfox, we plan to be a global, have a global system for communications. So we are already present in 29 countries, including 15 EU members. And if we make the computation of the population included in these 15 countries, because we're talking about the bigger countries, we reach 77% of the European population. So which is already, we start to be quite deployed and quite global as a network. And you see in this map, we are also addressing other continents, Australia, US, and South America, Asia from the beginning. And so this is growing as we speak. So I have this, basically it's my last slide for today. I want to have put some points on what is the best approach and what do we need to do to create this market and to increase and develop this IoT market, massive IoT market, and what is the need in terms of interoperability and what are the issues. So if we look at the past of Sigfox, so Sigfox has been active for 5 years on the market. What we see is that what is slowing down the take-up of IoT is not the lack of standards. It is, at least not in the connectivity layer, it is not the lack of standards. So you know, as everyone in this room knows, that there are standard coming from the 3GPP. There are solutions like Sigfox, there are solutions like LoRa, and there are other solutions which are proprietary. The fact that there is multiple solutions, we don't believe this is the major slowing point. We believe that the multiple solutions are addressing multiple needs, which are not always the same, and depending on what you need to do, if you want to connect sensors which need to send a very small amount of data, a solution like Sigfox is perfectly functional and perfectly useful. If you want to do automatic car driving where you need a lot of data, very high reactivity, Sigfox is not adapted. So some techniques, some standards are usable in some use cases, others in other use cases. What we believe is the point which is slowing the adoption of IoT is the fact that many companies, and here I'm talking about the B2B aspect of IoT, many companies are not yet ready to transform themselves into a digital company and adopt new processes inside their operations to benefit from IoT. So this is a big effort which is needed, and it's been started, but it is the major point which is slowing down the adoption of IoT, in our opinion. And so the third point on this is was what I said, there are complementary solutions from different standards. If we look at the interoperability point of view, we don't believe that we are ready today to fully define standards at the radio level. So there are some efforts. We are involved with ETSI, for example, to standardize some elements in the radio link, but there is still a lot of innovation to come. And if we limit by a standard where all this you will limit innovation. So it is good to have standards. It is good to be able to work outside of them and prepare the grounds for the future standards. So today we are in this phase. Of course, if we are talking about regulatory and issues, we believe that frequency harmonization across the globe is a good idea. So it's something which would be good to have. And it's not mandatory, but it's a good direction to have. And what we believe is quite important, and this is the topic of the previous talk as well, is interoperability at the data level. So being able to have an application on the cloud for a customer, which is independent on the radio technology which is being used. So it's Sigfox, can be LoRa, it can be 3GPP and IoT. I want my application, my customer wants to have an application, he wants to be able to connect some devices in Wi-Fi, other devices in 3GPP, and yet other devices in Sigfox, and all of them contributing to the same application. So this is quite important. So this is what we have. We are providing a very simple interface so that it's quite easy to adapt Sigfox output to systems which are existing and to make interfaces to these systems. And at last, we need to let freedom for the industry to innovate, and this is what Mr. Soriano said this morning. It's we need to let small companies invent new ways of working and create innovation and develop the market. So thank you very much.
So two challenges for the names. So my name is Patrick Guillemin, and I was a joke for every English guys, Guillemin, but I know some who can pronunciate. And the name of the alliance is the second challenge. So it's AIoTI. As a matter of fact, the head of unit, Thibaut Kleiner, who invented this name, is French. and thought about using aioli. You know the garlic mayonnaise, so we are close to the lunchtime. You replace the al with a T, and it makes IoT. So in fact, the name of the alliance is IoT. So you say IoT the alliance, or you say AIoTI. Okay. I'm chairing the working group 3, but all these guys, except the moderators, are members of AIoTI, and 2 of them are in the board. So Raoul, you was in the origin in the board of AIoTI, and Robert is chairing working group 4 on IoT policy. And in the previous session, you had Arthur, who is in 2 working groups, co-chair with Robert in working group 4, and chairing the groups on privacy and security. So plenty of people are members of the Alliance on IoT Innovation. And this is really great momentum, thanks to the support of the European Commission. So we have Frank Boissier in the room. Thank you for your support in creating this alliance in Europe. So this is the alliance of the European stakeholders supporting innovation and research. And I am chairing the standardization group. So we are a mix of all research, SME, innovation, standard, all together in the alliance. This is the picture. So perhaps you know this picture, crowded picture with lots of logo. In 2015, we created the first landscape of IoT with, in the same picture, alliances and standard organization. And we made the roadmap and the landscape. And we started from the research. We asked about innovations, and we identified with the stakeholders engaged, more than 30 liaised as SDOs and alliances. What are the gaps? So first gap, a common high-level architecture. Second gap, semantic interoperability or interoperability. Third gap, security and privacy, so it could be separated. And today, the other identified gap is IoT numbering. So we are studying IoT numbering in AIoTI. So it's a very hot topic for you as well. So each time we saw the engagement of the participant of the alliance, from all these stakeholders, you see research, standard organization, alliances, consortia, large-scale pilot. We are supporting the large-scale pilot on IoT. Test beds, this is like in IIC, the Alliance on Industrial Internet. Pilots, regulators, you are stakeholders as well. Policymaker, same, and directly companies. So this is the community engaged. And we deliver recommendations on architecture, on semantic interop, security and privacy. But we don't make standards in AIoTI. We put together the people, they reach consensus, and they come back to the standard organizations, and there are a lot, and they implement the good recommendations we are making. So this is the crowded picture. This is version 2.7. Lots of people reuse that picture, but this is not the only one. You have another one per verticals. You have another one with open source standards in reference implementations. And this is all for the introduction of Working Group 3. But HC has been supporting the Alliance since the beginning strongly. And we were funded for the Specialist Task Force 505 on IoT analysis that delivered an IoT landscape technical report and a gap analysis technical report. And today we are disseminating the recommendations we are making to the large-scale pilot for the IoT platforms developers on these critical aspects. So on the 7th and 8th February, we will host a European Commission hosted AIoTI workshop to disseminate to the IoT community our best recommendations on all these topics. Today you can download for free these 2 technical reports, and you can start like you with the IoT reports from RCEP, from berec. So this is how we proceed. We collect information and we discuss and we send recommendations. So there are plenty of identified standards, and there are lots in different verticals, mainly in communications and integration and interoperability and architecture. there are gaps. Gaps means missing standard or missing APIs, duplication of standards, or lacking of priority on the interoperability requirements. So we have surveyed a lot of people, and so there are in the technical reports the analysis of the survey. So today we're in the phase of disseminating, and we want to fill the gaps, resolve the gaps. So this to give you the structure, the working structure of Working Group 3 of IoTI. We have an IoT landscape. I need my glasses. IoT landscapes coordinated by Huawei, Giorgio Kayaganis, a colleague of one speaker. And we have the IoT platforms analysis task force, and we have the gap analysis platforms. We have high-level architecture, and the chairman is Omar here. IoT and identifications, and we have IoT semantic interoperability. We submitted a joint press release with IEEE, W3C, AOTI, and 1M2M with an outcome of AOTI that now belongs to the community. And thanks to Paul Murdoch, who is the coordinator. And we have Arthur, privacy subgroups leader and good coach. And we have another group on security, and we have Jacques here in the room from NXP, plus Arthur, and Harm from Verizon. So this is in cooperation with the Working 4 group of Robert on policy, IoT policy, which is more interested in the policy, trusted label, free flow of data. So he could have been in the first panel as well with Arthur. So I went back, sorry. So this is all I wanted to tell you, and the message I want to deliver is that people who are complaining there are too many standards, a lack of interoperability. We discovered in AIoTI, and now we are really partnering, that there is one common standard, like GSM in the world, for IoT. It's an M2M, it's an international partnership with CCSA, ARIB, so the Japanese, the Korean, the Chinese, the European, the American. It's called 1M2M. Now it's mature. The release 2 has been published in any place like CCSA in China or HC in Europe. No one can develop a new protocol interface to the device, to the gateway, to the server, to the applications. They cannot overlap. So everyone in the world can benefit from this unique standard in the world to implement it in its own implementation of the IoT platform. And this is also, if you like, available in the form of an open source project of Eclipse called OM2M. This is not the only one. And then you are leveraging the huge community of all implementers of 1M2M standard. So innovation is there, but for the consolidations of the implementations of the requirements into standards, you have 1M2M. So we discussed with IIC, with ITU, with IEEE, and we designed a high-level architecture that at high level is a common layer. So we have high-level architecture, and we have one international implementations available. So we are not lacking of this standard, it's there. So don't call again for a unique international standards for M2M IoT. We have one. Thank you.
Thank you very much, Patrick. I think that leaves us about 20 minutes for questions. So I'm going to open just with one or maybe two questions, and then throw it open to everyone here and hear your questions. So firstly, I guess a right to reply. Are any burning questions anybody here has, given you're now panelists as opposed to presenters, comments on other people's presentations that you really agree with or really disagree with? I guess it's a right to reply. If everyone's happy, that's fine. I'll then ask a more general question. Which comes first, standardization or demand? Sigfox, you mentioned it was the problem was a lack of demand. Everyone else seems focused on standards. Which comes first? Anybody want to take that?
if I gave the impression I wasn't focused on demand, then I don't think I gave a very good presentation. Because certainly we're focused on demand, and in its simplest form, we're responding to the needs of our customers. And we need to evolve as our customers' needs evolve, and that's the nature of the market we're in. It's a multifaceted market, and I think the slide I presented on just the different types of technologies that we need to deploy in order to meet those customer requirements illustrates, that we need to respond to demand first and foremost.
Okay.
So, as I mentioned, demand is quite important. What is quite important as well is to be able to meet the demand or to be able to fulfill the demand with in an easy way. So to provide solutions which are easy to implement. So I think this is the goal of at the end of the standard, is to make it easier to fulfill the demand. But at the beginning, you need to understand what the need is before you can you block everything.
Okay.
So it's not black and white. There are areas where we develop standards as the demand shows up because we develop and standardize at the same time. There are other industries where you have to know ahead of time. If you speak about 3GPP technologies, most of the time it takes 24 months to deliver products because there is silicon, there is radio, there is so many things that you have to deliver. So you have to know in advance, and you need to have a feeling of the future demand. In the area of IoT, I think right now what we are seeing is we want to deal with massive IoT, and there is a new demand coming up, which is this industrial IoT revolutions, where you have more real-time communications. In the industrial systems, you have new requirements, and this is now part of requirements for 5G. So it's not black and white. Everything we do has to adhere to a certain market demand because we are industry stakeholders. And sometimes we standardize, then we implement, and sometimes we standardize and implement at the same time.
So the gap between the innovators and standards is filled by the adoption and support of open source software reference implementations. Today, in HC, we experience lots of new groups who are developing standards with proof of concept implemented in open source, very close to the market and requirements. So there is no more gap between the innovators going fast, quick, answering the needs and the demands, and the standard maker lagging behind years after producing the standard. It's no more true. We have good examples in the Navy, and not only 1M2M as well is having lots of reference implementations. So I think standards are in HC, for sure, in 1M2M as well, are close to the demand.
Thank you. So I guess it's a two-way thing. Demand drives standards, and standards unlock more demand. So it's a two-way relationship. Questions? Any questions about it? Carla.
Being an economist, I have I'm Kara from BNetzA and berec. I obviously am trying hard to follow these concepts, and the concept of having a separation between the service and the connectivity obviously sounds very appealing in the long term because it seems to guarantee some openness. What I would like to ask Raoul and Robert is to what extent how they position their business model vis-a-vis this concept of connectivity and service separation.
Okay, I can start maybe. So, what we believe, there is an application. So this is the service has to be to fulfill this application, and then there is the mechanisms to make this application exist, and which amongst other things requires some connectivity. So connectivity is one element, and as Sigfox we are focused on the connectivity part. we have designed a technology which allows, which has some good properties for connectivity of a specific family of objects and applications, and therefore we deliver this connectivity and as a subscription on a subscription basis. So and it is not. So I think the connectivity is just one element of the service. I don't know if I fully answer your question.
I would say
Thank you. Connectivity is important. As a company, we also want to diversify. Maybe I'll give you one example just to illustrate that in the automotive sector. So there's a part of Vodafone called Vodafone Automotive, and that's an example of us, moving beyond just pure connectivity and offering value-added services to customers. And that results in a lot of additional services in the automotive sector. Usage-based insurance would be one example. So that's an example of what we try and do in terms of diversifying and developing beyond connectivity, because there is a lot of value-added functionality associated with IoT.
Can we go on, please?
so. I think in this example that was presented by Robert, he presented a Vodafone platform which delivers services to those application providers in the IoT domain. That's one model. There are other models where an energy provider want to deploy its own IoT platform. This is a perfectly valid one, and it's happening today. And for that case, they have to work with different connectivity providers. So it's a business imperative to mix and match the connectivity providers. And in protecting the user's interest, it's also very important, this flexibility to switch or to change or to cope up with new connectivity schemas or to have any-to-any communications. So for me, it's almost a business imperative, and it's if we spoke about market demand, this is part of market demand, and this is, I think, the whole reason for which the operators have been working on this eSIM and those different discussion about changing the network subscription.
Can I just circle back on this and take Kara's question, and I'll push it to another level of detail, because I think the question was about unhinging connectivity from services. And I would say, Raoul, that in your case, that's impossible. And I'd say that in your case, down the end, Robert, in Vodafone's case, that's all but impossible, particularly if you look at the multiple services that are provisioned across GDSP. So the satellite services, the fixed services. Somebody wanted to pick that service up and take it somewhere else and use somebody else's connectivity, they'd basically be building it again ground up. And I'd say that if you pulled that back to just focusing on mobile, the simplest case, frankly, even in that case, it would be probably staggeringly difficult. So practically these things can't be unpicked. Any comments on that?
So I have to lean over again, use this microphone. What I endeavored to set out was the ability to change connectivity provider. I mean, that's what the GSMA specification facilitates. Is that the point? I mean, I'm trying to address the point, but the staggeringly difficult point. But what we're trying to do as an industry is to enable customers to essentially, choose their connectivity provider and retain the degree of functionality that they want.
But when that's built into an application and the application is managed through GDSP, through the connection, through into the device, and you're managing things on the device, what you've not just got a simple connection, you've got a whole solution which leverages part of the GDSP and into the device.
But is that not, that's competition? I mean, someone else might have their own platform, might say there's a jolly good range of features associated with that, and the customer might like their features better than our features.
I agree. I think it's fair, but to think it's quite difficult. I mean, it's logically sensible to have connectivity and services. The practicality of it in today's market is pretty hard to unhinge those things. And to unhinge those things, you'd need some basically homogeneous operating environments in the remote devices and a standardized platform. That's a level of standardization which is decades away.
Okay, if I have a Sigfox device, there is no way that I can make a Sigfox device work for another network. It's meant and designed to work for a Sigfox network.
Yeah.
There's no way
it.
around this.
But yeah.
But if you speak about the car industries, they ship with, let's say, 2G or 3G or 4G. And those can work with Vodafone, can work with anyone from a network subscription point of view. As a matter of fact, if you take the case of Denatran in Brazil, for years, they have this service. They can switch the provider for years. And they dissociate completely the network subscription from the service subscription. So it's possible. There are certain limitations in very specific cases. And I agree with your statement. But in practice, it's possible.
Okay. Others?
Thank you. Hello, thank you. So, Raoul, on your point again on the culture, I don't think it's about the demand side, it's about the culture. That you mentioned the word culture, and that is your major challenge. So I think on culture, it's not only the end user, but it's also everybody in between. Because when we talk about interoperability, it's not only about trying to make it interoperable between the service providers that are existing already and the end user, but of course the large platform economy that we want to build here in the European Union, right? Mm-hmm. So if you look at culture and you look at the platform economy and the end user, so instead of that it's an issue, I understand, how can we solve this? What are your recommendations to try to solve this riddle?
So I don't know if I use the term culture or maybe, but what I meant is the fact that if I have a company with a given process with people who are going to collect, to measure, well, to read the meter reading in all the homes once every 2 months, for example. If I'm doing a connected water meter, I don't need these people anymore. And then what I need is data scientists to collect the data and do stuff with this. So this is a transformation of the companies, and it's a big challenge because for all of us, it's a big challenge. But this is of course the extreme case. So what we need is of course more education. You need to improve. But we also need to change the economy or the businesses so that they're able to build the knowledge internally to transform themselves. This is what I meant.
It's Danto Fan from ENISA. I saw 2 proposals of frameworks or devices that are going to be used, let's say, between the devices, the IoT devices and the providers. Are you planning to also cover some security-related issues with these frameworks or devices, or it's just for connectivity and it's just for, let's say, the ease of access? I saw Vodafone and Sigfox proposal, so I think the question is for them.
Yes, I need a rephrasing of the question because I've not fully understood what you mean.
So you showed in your presentation some devices, I understand, that you are going to provide, or some frameworks that the clients are going to use in order to connect their devices, yes, to the internet. Are you planning through those frameworks or devices to cover also some issues related to security, to cybersecurity? So that to cover, let's say, the big amount of vulnerabilities explained in the first session, or is just going to be this is something that is left out to the care of the customer or the care of the producer?
Okay, I can elaborate a little bit. Of course, I did not go into the detail because it was just a limited amount of time. So, what we have, of course, there is security design in the Sigfox architecture. And there are solutions to secure data on the devices, secure data on our network. But at the end, the customer needs to be also involved in the security because the customer is at the end is making the device, deploying it, and is building the application. So everything has to be secured from end to end. So we are providing building blocks on our side, and we are providing recommendations on how to best implement the device so that we have enough security, enough privacy, and encryption of the data and everything.
Can I take? So security for IoT is not an option. It's a must-have. But there is no single security mechanism fits all the use cases. Security is a toolbox that you have to adapt with respect to use case, because if you put the bar very high, you end up with high-cost security solutions. So you have to adapt to the threats that you have. One other comment, we think that it goes hands in hands with device management, because security is a moving target. So as time goes on, the hackers will come across new vulnerabilities, and you have to update the software and the firmware and the keys. So it goes hands in hands with device management, very important concept. So it's not an option. There is no single security mechanism fits all. It depends on the use cases and the vulnerabilities, and security and device management should be going hand in hand.
Okay.
I think it was targeted to you as well.
Other than obviously to highlight, security is incredibly important. If the offering isn't secure, then we can't commit to provide our customers with the right level of service. So as I said, this isn't a prospective deployment. This is what we're doing already. And I would say that leveraging existing SIM card functionality, there's already a number of best practices there that we can rely on ensuring a secure mobile IoT proposition. I also know, for example, we have representatives on the ENISA Connected Car Task Force for automotive security. So we want to contribute to the debate there as well.
Okay. One quick addition. No.
She said it's over.
Over.
Well, we were going to go for an extra 5 minutes about 3 minutes ago, so we've got about 2 minutes left, by my counting. Do you want to make that quick comment, and then we'll wrap it up?
So very quick, back to security. The big challenge is constrained devices. We cannot apply the same security protocols like TLS today. It's very hard to apply in constrained devices. So there has to be certain evolution to the protocols for security.
Okay. That. We have more questions. I'm afraid we're out of time. We've run out of time. So please bring your questions up to the front and catch these people before they run off to lunch. But thank you for joining the session, and thank you for asking all the questions. And thanks to the panelists.